Welcome to the introductory session on model logic. Before we start discussing as to what a model logic is, let us try to understand why we need model logic. Let's say we have an argument P is valid, P implies Q is valid, therefore Q is valid. If we need to be symbolizing this in propositional logic and check for its validity, we can use the symbols A, B and C respectively to indicate P is valid, P implies Q is valid and Q is valid. Doing so, we would be getting the formula something like this. A comma B satisfies C. Now, if we need to be proving this using propositional logic, we are not going to be able to do it. Hence, propositional logic would not work for such type of arguments. Now let us see whether predicate logic would work for symbolizing and checking for the validity of this given argument. If I am going to be using a unary predicate P to indicate is valid, then the given argument would get symbolized like this. P of P for P is valid, P of P implies Q for P implies Q is valid, and P of Q for Q is valid. Here, the symbolization itself is working out to be wrong because a predicate's argument cannot have a connective. So, predicate logic is also not working for the given argument, which means we need to think of a different approach that would help us to symbolize and check for the validity of the argument. Now let us consider one such different type of symbolization and see whether it would be possible for us to consider having this symbolization and checking for the validity of the argument. Let me say that I'm going to be using a unary connective which is going to talk about the validity which is represented in the argument. So I'm going to use box X which indicates that X is valid and check if I can symbolize it and see if I can use some meaning being associated with it and check if the given argument is valid or not. So first of all, let us look at symbolizing it. So when I say I'm going to use box P to indicate that P is valid, then I would have box of P implies Q for P implies Q is valid and box Q for Q is valid. So once we get this symbolization, the given argument becomes a formula like this. Box P, comma, box P implies Q entails box Q. Now we need to associate meaning for every symbols and see how we can have the rules that would help us to check for the validity of the argument. And the logic that we use for whatever different symbolization we have discussed in the previous slide, we call it as model logic. And if we have to talk about model logic, it is nothing but an expression that is used to qualify the truth of a judgment. And we also can say that it is study of principles of reasoning involving things like necessity, possibility, and other such related concepts. Say, for example, it could be impossibility, contingency, strict implication, certainty, and so on. Now, if we look at what a model logic is, it's nothing but an extension of the classical logic. It's just that we are going to be adding more connectives to it. So more so in our case, which we are going to be discussing, we would be using two connectivities. One is called as the necessity and the other one is the possibility. So with that said, I said we can have other related concepts also. So it leads us to many types of model logic. Here I'm representing a few of them, and more so we are going to be discussing about the alethic logic, which is also known as crepe logic, where we are going to be talking about necessity and possibility as the qualifying factors for the judgment of the truth. Apart from that, we have epistemic logic, where uncertainty is being considered, and temporal logic, where the tense is being considered because the timeline is being considered there. And computational tree logic is one example, and we are discussing that also. And deontic logic talks about the morality, and doxastic logic talks about the belief. But our more often we are going to be concentrating only on the crepe logic. Before we dwell into looking at the syntax and semantics of crepe logic, let us just see how it is going to be different from that of the propositional logic. Crepe logic is nothing but an extension of the propositional logic, and we are going to have two connectives added to it, and two unary connectives, to be more specific, added to it. So thus the alphabet set of crepe logic is going to be something like we are going to have the atomic model propositions that were used in propositional logic to be used here also. Apart from that, we can have the predicates being used here, and unary connectives, as I said, we have negation in propositional logic. We are adding two more connectives here for crepe logic. And binary connectives, whatever we have used in propositional logic, is applicable here also. And the propositional constants, truth and false, are the constants here in model logic also. And the punctuations, the open parentheses, comma, and close parentheses are going to be acting as punctuations even in model logic, that is the crepe model logic. And quantifiers for all and there exists could also be used in crepe logic. Now let us just take one simple example and see how we can symbolize it before we move on to discussing about the syntax and semantics. If, for example, I have an argument like if parents are dead, then the person is considered to be an orphan. Yanka believes that his parents are dead. Therefore, Yanka believes that he is an orphan. So in order to symbolize this, first we are going to be looking at what is the connective we are going to be using, and if we are using any predicates, what are they and all. So in the case that we are considering, we are going to be looking at two predicates, one for the parent being dead and the other one to represent orphan. So I say dx is going to be used for indicating x's parents is dead, and ox is to represent that x is an orphan, and box is going to be used to specifically represent Yanka believes, and y is the variable that is used for Yanka. With these assumptions, if we are going to be symbolizing this, then dx implies ox is the first sentence. That is, if x's parent is dead, dx indicates that x's parent is dead, then x is an orphan. And we have that Yanka believes that Yanka's parent is dead, and so it is symbolized like this. And it is also said that Yanka believes that he is an orphan. So Y believes that he is an orphan. Thank you.